So in this video, I'm going to show you how you find the value of a trig function at any angle. And before I do that, I want to just talk about, well, which trig functions are positive in each of the four quadrants. So here in quadrant 1, you can see that the cosine is positive because all the x values are positive. The sine is positive because all the y values are positive. And if the sine and the cosine are both positive, that means the tangent is also going to be positive. So in here, we have all three of the trig functions as well as all three of their reciprocals. So there, all of the trig functions are going to be positive. If we come over to the second quadrant, you can see here that the x values are negative and the y values are positive, meaning that the cosine will be negative, but the sine would be positive. And if the sine is positive, obviously its reciprocal is positive, but the tangent here would also be negative because the tangent is the sine over the cosine, which would be a positive divided by a negative. In the third quadrant, the y values are negative and the x values are negative, which means the sine and the cosine are both negative as well as their reciprocals. But since the tangent is the quotient of a negative number and a negative number, that's going to come out to be a positive value. So the tangent is going to always be positive in the third quadrant. In the fourth quadrant, we have positive x values but negative y values. So this means that the cosine is going to be positive while the sine is negative. And if the cosine is positive and the sine is negative, those are opposite values. So the tangent as well as the cotangent here would both be negative. So what does that mean? It means that the sine is positive in quadrants 1 and 2. The cosine is positive in quadrants 1 and 4. And the tangent is positive in quadrants 1 and 3. So the way that is easiest to remember it is that we put an A here because all of the functions are positive. We'll put an S here because just the sine is positive as well as the reciprocal. We'll put a T in the third quadrant for the tangent, and we'll put a C in the fourth quadrant for the cosine. So it's ASTC. So some students remember that it spells cast, or the common saying is that all students take calculus. And that goes in order of the quadrants. So A for all, S for students, T for take, and C for calculus. So all students take calculus means that they're all positive here. The sine is positive here. The tangent is positive here. And the cosine is positive over here. Now, if we wanted to use our knowledge then of the unit circle to simplify something like the tangent of, let's say, a 14 pi, over, that didn't work very well. Let's try that again. The tangent of 14 pi over 3. Now, the issue here is that 14 pi over 3 is not listed on the unit circle. What I have to look at here is an angle that if I consider it in standard position, it has since gone all the way around more than once. So that would be 2 pi. Right? If I went around a second time, that would be 4 pi. Went around again, that would be 6 pi. So what I have to do is I have to figure out, well, how many rotations are there in this value right here? So what I'm going to do is I'm going to take my 14 pi over 3, and I'm going to subtract a full rotation from it. I'm going to subtract 2 pi from it. And I want to make sure that I get this number, this 14 pi over 3. I want that to be decreased so it's somewhere between 0 and 2 pi. I want a positive angle between 0 and 2 pi. So I'm going to keep subtracting out rotations. I'm going to subtract out one rotation, so I'm going to subtract 2 pi, and that's going to give me 2 pi is going to be the same as 6 pi over 3. That's going to give me 8 pi over 3. Well, 8 pi over 3, that's still too much, right? That's still more than a full rotation. So I'm going to subtract 2 pi again. And that's going to give me 8 pi over 3 minus 2 pi is going to give me 2 pi over 3. Well, 2 pi over 3 is a number I can work with. I see that in my unit circle. It's right over here. So that means that the tangent of 14 pi over 3 is really equal to the tangent of 2 pi over 3. So all I need to do to find the tangent of 14 pi over 3 is to find the tangent of 2 pi over 3. Well, the tangent of 2 pi over 3 is equal to the quotient here, right? Tangent is going to be the sine over the cosine. So the tangent of 14 pi over 3 is equal to the sine, which was root 3 over 2, divided by a negative 1/2. And so what that really means, we're multiplying by the reciprocal. So root 3 over 2 times a negative 2 over 1 is going to equal a negative root 3. So that means then that the tangent of 14 pi over 3 is equal to a negative root 3. Let's try another one. So if we had, get rid of all this, let's try one with a negative value this time. Let's say we're going to have the secant of negative 17 pi over 4. Okay? Well, negative 17 pi over 4, first of all, is a negative number, and I want to have a positive reference angle. I want my reference angle, I want theta to be greater than or equal to 0, but less than or equal to 2 pi. I want theta to be somewhere in that range. So that means I have to take my negative 17 pi over 4, and I need to continually add 2 pi to it. So negative 17 pi over 4 plus 2 pi. 2 pi is going to be like 8 pi over 4. That's going to equal a negative 9 pi over 4. Not enough yet. So I need to add 2 pi again. And that's going to give me a negative 1 pi over 4. Still negative, and I want positive. So this is going to be plus 2 pi one more time. And that's going to give me a 7 pi over 4. Now, 7 pi over 4 falls within this range. 7 pi over 4 is between 0 and 2 pi. In fact, I can see 7 pi over 4 on my unit circle right over here. So that means that the secant, remember the secant is the reciprocal of the cosine, and the cosine is root 2 over 2. So the secant of negative 17 pi over 4 is equal to the secant of 7 pi over 4. All right, those are going to be the same value. It just means that the negative one has gone around the circle several times, 3 times to be exact. And then, so what we're going to do here, this is really like 1 over the cosine of 7 pi over 4. So this is really like the reciprocal of root 2 over 2, and that's the reciprocal is going to be 2 over root 2, and if we rationalize the denominator, that's going to give us 2 root 2 over 2, and the 2's cancel. So I can say now that the secant of negative 17 pi over 4 is equal to root 2. And that would be my final answer there. So I hope this kind of helps you. You don't necessarily have to write it out like this every single time, adding 2 pi, seeing what it comes out to. If you sort of know that how many times you have to run around the circle to get back to a positive answer, you can. But you want to make sure that your reference angle, theta, is always going to be between 0 and 2 pi. I hope this video helps. Good luck.